I just received Tom's part in the mail, and it's looking really good. Everything's a little bit oversized so that it can be ground to match. So it's a little bit bigger than this slot is. I also made my slot narrower, so I got to take material off here and off the outside of his part. He left 3/1000 aside to be removed so that there's a nice finish. And so I've just got to finish this guy here, which I've been kind of hemming and hawing at. So first we got to drill a couple 632 holes in the top to mount some future option on. That was part of Maddie's design that I just carried over. I couldn't actually imagine what it was for, but I'm sure there's some good ideas associated there. And then we got to cut the 20-degree portion off of this and then do the 20-degree slot. That is going to be challenging work holding after I get to that point. So let's start with the easy part and drill and tap. And I say easy, but drill and tapping in pre-hardened material might not be so easy. Never really done it. So we'll give it a shot. So let's just drill and tap 2 holes, and I'm going to center drill them first. So I got the holes started, and I will bottom tap these. I also drilled the holes so they're only like 60% threads or 55% threads. Because of the material being pre-hardened, I wanted to give myself that little bit of a lead. So now we basically have to remove all the material until we reach run edge, put it at 20 degrees. So I've got a couple of 20-degree angle blocks with stops here, which are a very useful design. And I'm just going to set it in here. Here's a little bit closer look, and the beauty about what I got going on here is that the thickness of the stock is 0.5040, 40,000s over 0.5, so a couple 1/4 inch parallels, a couple 1/4 inch angle blocks won't touch the part, and I can still clamp it. Just try to see how this guy cuts. So I'm double checking between cuts to make sure that the part doesn't move, because this is not an ideal way to go, but cross-cutting wasn't working very well. So pushing into the vise that direction, which makes more sense, was having a little more issues. So I found something just above my final 0, so I know when I'm getting close, and I zeroed my DRO on that, so I can slowly walk it in at that point. So we're going to do another 4/1000s. And we're going to call that good. We're going to grind the rest. So I don't know if you can see this right here. It's not a perfectly straight line. It angles back a little bit this way. And what that kind of says to me is that maybe the tram of my head has moved since the last time I trammed it, which was, I don't know, 2 or 3 uses ago. And so that means it's cutting a little bit more on this side than it is on this side. So we need to fix that. But I'm going to grind the rest in, and we will come back. The face wheel actually did a pretty decent surface finish, all considering I've just deburred it. And you can see there on the end what I'm talking about. While it's not a perfectly perpendicular line to the face, because I ground the faces parallel to each other, and so you can see that should also be a perpendicular line, which it's not, which means probably head trim, which I will double check. And if you're wondering, it did not slip off the blocks. That is a really good fit on the block. So So this part ultimately is going to match this part. But before I move forward, I need to square this guy up and remove the excess material he left on here for me to probably get rid of some of the tooling marks. So it's 3/1000 aside except for this end here, which I'll just dust off just to clean it up. But the other sides, we're not looking for anything in the tenths or anything like that. We're just looking for something nice. This is a machinist jack. So as I'm dusting off the outside parts, I'm not going to film that part because surface grinding is sort of hard to get on camera because the camera always needs to be right where I need to be. So, but when I set up for doing the inside here to grind out the inside, then I'll bring you back because that's going to be involving a process I've never even done before. So I've got to side grind these things, the walls here, because apparently he got a little bit of a taper in there, and we need to take that out. And then once I get that final dimension, then I will grind this one to fit in there very nicely. So I'm not quite sure how I'm going to pull that off, but I'll bring you back in a bit. So what I did was I got my magnetic sign plate, one of my prides and joy, used Suburban Tools magnetic sign plate that I got, very fantastic. Set that up at 20 degrees with a bunch of gauge blocks, tightened it down. Then I dressed a 1/2 inch wide wheel. There's a 1/2 inch slot. This is really close. It would have been better with a 1/4 inch wheel. Didn't have it. I relieved a bunch of material except for like the bottom 1/8 inch here on the sides. So what I'm going to try and do is get the center first, and we're just going to try and clean up the bottom of the center first, and then we're going to try and side wheel and clean up the sides and get them square. And then once I've got that dimension, I can cut my other part to match. So I don't know if showing this, it's going to, be useful to show this because the camera's in my way, so I don't know if I can give you a really good angle to see what's going on. But this also is a pretty big bite, another reason to have a 1/4 inch wheel. So I'm going to try and just go down a couple tenths at a time. Several minutes later. Hopefully you can see this, but we've cleaned up the bottom. Now we're just going to try and side wheel and do the sides. I've never done this, so it's going to be pretty challenging, I think. Even more minutes later. All right, so I don't know if you can see this, but I cleaned up both sides with side wheeling. It worked out very well. This is a very open structure wheel, 46 grit, and I think that turned out beautifully. Now, whatever this width is what I'm going to try and match with the other piece, rather than go the other way around. This was a lot easier. I actually got a little bit of burrs on the top. That's amazing. Beautiful finish though. All right, let's make the other piece match, the angle. So since I've got the compound set up, I'm gonna flatten the angle on the other one to match, because no better time than the present, because this is the exact complement, well, no, it's the exact identical angle, and that way I know they'll mate perfectly. One thing that's really good news is that it's taking an even cut all the way across, which means that the angle I got originally is very close to correct. All right, so this is extremely smooth. I made it about 4/10 undersize, 3 or 4/10. It is a really close fit. You can't feel any wiggle at all. And what I had to do, besides chamfering the bottom, was relieve the bottom section a couple thousandths on both sides. And what that allowed it to do was to make up for the fact that apparently the wheel deflected a little bit on the bottom. It's not perfectly square on the last, 25 thousandths at the bottom. So I'm pretty happy with it though. It's very, very smooth, no wiggle. I think it'll be very nice for Max. Alrighty, so I just ground this guy and just cleaned up the sides. It's amazing just setting it on there. It scratches. It's not that hard. It should be nice if it was a little bit harder, because I cleaned everything every time, but still ended up with some scratches. And then while I was surface grinding the inside section here, I slipped with the infeed and buggered the corner of this and heated it, which is really bugging me. It doesn't affect the quality. I still have to drill a hole, a clearance hole through here for 1/4 that'll go into the bottom of this guy, and also have to do the relief for the head. That's coming up next. But here's the fit. It is a really nice fit. It's like a 1/2 thousandth oversized, just like this guy was. So here's where we are. And I calibrated this height here. Ooh, I think I have to take a little bit off because this is protruding back. When this is flush, this might be sticking up high. I need the rear piece to this guy because I need to make sure that this thing's not proud, because right now this height combined is 2 thousandths under the height of the Kurt vise, and this is just a little bit more than that. So we're gonna have to fix that. We got to remove a little bit more material off the back side of this guy here. All right, so we're getting down to the last couple operations here. One thing I need to do is tune the thickness or the height of this guy when it's all the way back against the end here. So I've clamped a piece of ground stock up against the back, just with a really quick grip vise here. It doesn't matter because it's the material that's pushing flush against the ground section that matters. That's just providing a little bit of force. See, this is a little bit proud, and I only gave a couple thousandths clearance for the comparison between the height of the Kurt vise. So what I need to do is I need to measure how much material I need to come off. So we need to drop this down, set my 0. All right, so this is a little awkward. So this is a tenths indicator that I've got on here. So we're sitting at 0, and it's going to step up a little bit here to get up here. And it looks like we have to take off about 4/10 of material to make it flush, 3.7. So we're going to set this back up in the grinder and take it down about 4/10. That's it. Several minutes later. All right, tough to show on the surface grinder the work there, but you can see that we got a very nice fit now when this is all the way back. All right, so the final operation I need to do is this guy here gets a pin. It gets a 3/16 pin through here, but it's set up as an interference fit, and I don't have any undersized pins for that. So what I need to do is I need to just verify the height of this pin above the base of this slot here. Alrighty, so I found a pin that'll fit through here. It's 0.186 instead of the nominal 0.1875, which makes sense. It's 1.5 thousandths undersized. And then I went and found a couple of pins. Here's one that won't fit underneath here. It just starts to fit underneath at this side, but won't fit underneath at this side. So there's a slight angle on this guy. And here's 0.162. 0.162 fits underneath. The calculated value should have been 0.156 off the base, so it's a little bit off. It's about 6 thousandths off, and that could be because I machined this. I didn't machine this sloping portion to any specific depth. I machined it so that it would be just cleaned up because I didn't know how much material I could take off. And so that's my bad. Tom probably had his hole spot on. All right, so here's my work holding situation. 2 1/2-inch parallels, a 20-inch angle block that mates up with the 20-inch angle on top, and then just tightening the vise into that whole thing. It's supported by about 3/4 of its height there, and then we're going to put the slot down here where the parallels are not. First, I'm going to pre-drill out most of the material. I'm going much under the size this time. It's a 3/16, and I'm going to a 1/8 inch drill bit. In addition, this drill bit is solid carbide, so hopefully that'll make it minimal deflection and I won't have any problems. So we're just going to drill as many holes as we can to remove a lot of material that way. This is fairly thick material considering the depth of the, it's 1/2 inch deep hole, 1/8 inch wide. That's a 10x hole. That's quite deep. So, or slot ultimately. So we're just going to take it slowly and see what we can do. You may be able to see here that the last hole is not evenly spaced. That's because I didn't want to risk breaking out the sidewall when I was drilling a hole. So instead of spacing them 125 thousandths apart, which is an 1/8 inch drill bit, I went 130 thousandths, so that's the cumulative error. I almost could fit one in between there, but not quite. All right, I have an 1/8 inch end mill in place, and I'm going in 25 thousandths depth. which is going to mean 20 passes, but so be it. One big advantage that I hadn't considered in this approach of pre-drilling the holes was a significant advantage actually, which is that the holes I pre-drilled have given a place for the chips to go, so I don't have to worry about recutting chips because they're falling right through for the most part, which is pretty fantastic, because with small end mills, if you get chip wedging, that can definitely cause a breakage. So this was a good approach. Just got to make sure you use a small enough drill bit when there's a little bit of deflection. It doesn't cause you to cut into the side of what you intend to be the final wall. All right, so we are through. I know you can't see it from this angle, but we're all the way through. There's a little bit of scalloping. It's surprisingly good. That solid carbide drill bit really cut, you know, right on center for the most part. Only a tiny bit of deflection. There's only a little bit of scalloping in there where you can see that the drill bit wandered a little side to side, or perhaps the end mill. It's a solid carbide end mill, but the center portion of the end mill is probably not as thick as the drill bit. I'm not actually sure the web. In any case, it turned out really good. So now we're going to go up in size, and we're just going to try 3/16 and clean this up. Be done. All right, so we came down to this side an extra 3/1000 just to give a little clearance. That will leave a little bit of slop. I got to deburr this, but it's a beautiful finish in there. I don't know if you can see it. So I think I found my approach for next time when I have to drill a deep slot in something. Just go well undersized with the drill bits, remove most of the material, and then come back with a larger one after you're done. And it took a couple passes back and forth just to clean up all of the little ripple marks. I was at 1600 RPM with this size end mill. All right, so here we are with my part done. I didn't screw the top to the bottom. It's just sitting there at the moment. I think it lines up nearly perfectly. This is a 0.186 instead of a 0.1875 pin in here, and it's going all the way through. And we've got a very, very smooth fit right here. It's pretty nice. And I think we're good. I went a little bit over on the slot width so that if any material ever had to be taken off, it could. So I let it, so it went a little bit proud of this side, which will be stopped by the end plate anyways. And then it goes up for the little over 0.5 inches of coverage. So it's got a ground finish pretty much everywhere. One thing I thought might be useful would be to put some relief slots in the bottom here so that it didn't make contact everywhere, so when there's a lot of pressure pushing down, it came freely. But it's so smooth that I didn't bother. We'll find out when Tom assembles the whole thing. But I think we're good to go. They just need to put the end cap on and the screw, and this project should be done. And we can send it off to Australia, where Maddie's making a box, I believe. Anyways, I'm not sure about the latter part, but I think that's right. Anyways, thanks for watching. Hope you find it useful. Hope to see you next time.